Good morning, students. Topics for today are efflorescence, deliquescence, hygroscopy. So, open your chemistry concise book page number 43-44. So, before proceeding further, let's start with today's objectives. So, the first objective is to understand the meaning of efflorescence along with examples of efflorescent substances. Second, to understand the meaning of deliquescence along with deliquescent substances. Third objective of the today is to understand the meaning of hygroscopy and examples of hygroscopic substances. Fourth one is the factors on which these properties depend, and the last one is to know the difference between these three properties. Now let's start with our first objective. The first objective is efflorescence. So efflorescence is the property of some salts to lose wholly, means completely, or partially their water of crystallization when their crystals are exposed to dry air. So they become powdery. Now what are efflorescent substances? Efflorescent substances are solids that can undergo spontaneous loss of water from hydrated salts. Here comes the question, what do you mean by hydrated salts? So, hydrated salts are inorganic salts containing water molecules combined in a definite ratio. Let's start with its most common examples. The first example is of washing soda. Formula is Na2CO3 10H2O. Its name is sodium carbonate decahydrate. So what about the reaction? When it comes in contact with dry air, hydrated sodium carbonate loses its 9 molecules of water and become monohydrate. Next one is Glauber's salt. The formula of Glauber's salt is Na2SO4.10H2O and its chemical name is sodium sulfate decahydrate. So again, when this sodium sulfate decahydrate comes in contact with dry air, it loses its 10 molecules of water and becomes white powder, that is sodium sulfate. A common example of efflorescence is drying of cement or a white deposit of mineral salt on face of concrete or plaster walls in abandoned buildings. In chemical language, it is known as calcium sulfate efflorescence. So here comes the factors on which efflorescence depends, that is temperature. The higher the temperature of the air, the higher the rate of efflorescence. Now let's start with our second objective, deliquescence. So deliquescence is the process or phenomenon by which a substance absorb moisture from the atmosphere to become moist and ultimately dissolves, forming a saturated solution. So deliquescent substances are the solid inorganic salts that get dissolved by absorbing moisture. These deliquescent substances have high affinity towards water. So let's start with its examples. First one is sodium hydroxide, formula NaOH, caustic potash, KOH, ammonium chloride, NH4Cl, magnesium chloride, MgCl2, ferric chloride, FeCl3. These deliquescent substances are usually used as desiccants. You can say substances used as drying agents. For instance, when the water vapor inside a container has to be removed in order to stop a particular reaction, these substances can be kept inside the container. These will absorb a high amount of water and prevent the interferences coming from water vapor. Now, coming to its factor, again temperature. The higher the temperature, the lower the deliquescence. It means deliquescence is minimized during dry conditions or non-humid conditions. So let's start with the third objective, hygroscopy. Hygroscopy is the phenomenon or process in which some salts absorb moisture from the atmosphere without dissolving in it. So, hygroscopic substances. Hygroscopic substances are the solid inorganic salts that can absorb moisture from atmosphere without changes their physical state. So, when water vapor is absorbed by hygroscopic substances, the water molecules are taken into the spaces of the crystal structure. This causes eventually increase in the volume of substance. Now let's start with its examples. So first example is concentrated sulfuric acid. Now second is phosphorus pentoxide, P2O5, quicklime, CaO, silica gel, and then is the zinc chloride. This is ZnCl2. Now coming to the factors. Again, hygroscopy minimized during dry conditions. It means hygroscopic substances have a tendency to take up moisture from the air. Now, I am going to start with some tips by which you can easily understand the difference between these three properties. So, first one is water vapor absorption. In case of deliquescent substances, it can absorb a high amount of water vapor. Efflorescence do not absorb water vapor and becomes powdery. Hygroscopic can either absorb or adsorb water vapor. So here comes a definition: adsorption. Adsorption is actually the process by which a solid holds molecules of a gas or liquid or solute as a thin film. So the second one is other names. Deliquescent known as desiccants, efflorescent known as crystals, hygroscopic are called humectants or even desiccants in some cases. So the third one is affinity for water. Deliquescent, they have strong affinity for water. Efflorescent, no affinity for water, and hygroscopic, they have a less affinity for water as compared to deliquescent substances. Fourth one is formation of solution. Deliquescent forms aqueous solution by absorbing water vapor. Efflorescent do not form solution, instead they form powdery mass. Hygroscopic do not form solution but absorb water. Now open your books page number 43. Under the heading properties, let's start with first definition: efflorescence. A phenomenon where a compound loses its water of crystallization on exposure to dry air is called efflorescency, or you can say efflorescence. This results in loss of crystalline shape and finally the crumbling of crystals into a powder. So substances showing efflorescence are called efflorescent substances. Efflorescence occurs when vapor pressure in the hydrated crystals exceeds atmospheric vapor pressure. Thus, it is minimized during human conditions. Now, let's start with our next definition, that is deliquescence. Deliquescence: certain water-soluble substances, when exposed to the atmosphere at ordinary temperature, absorb moisture from atmospheric air, becomes moist, loses their crystalline form, and ultimately dissolve in the absorbed water, forming a saturated solution. Such a substance is called a deliquescent substance, and this phenomenon is called deliquescency, or simply you can say deliquescence. Deliquescence occurs when vapor pressure inside the crystals is very low as compared to vapor pressure in the atmospheric air. Thus, deliquescence is minimized during dry conditions. Here are the examples of deliquescent substances: caustic soda, NaOH, caustic potash, KOH, magnesium chloride, MgCl2, zinc chloride, ZnCl2, calcium chloride, CaCl2, and ferric chloride, FeCl3. Now the third one is hygroscopy. Hygroscopy: certain substances absorb moisture or water vapor from the atmosphere when they are exposed to it, but not enough to form solutions. Such substances are called hygroscopic substances. The phenomenon is called hygroscopy. Some examples of hygroscopic substances are concentrated sulfuric acid, phosphorus pentoxide P2O5, and quicklime CaO. So, to better understand topics like efflorescence, deliquescence, hygroscopy, I am going to attach videos with it so that you have better view of these three terms.